Focus is going to be on multiplying fractions by a proper fraction. So to show that using an actual fraction, I'm going to begin with the problem 2/3 and 2/3 and 2/5. So if I want to take 2/5 and multiply it by 2/3, I know that my denominator is going to be telling me the number of columns that I need. Well, if I'm going to have 2/3, I need at least 3 columns so that I could have my 2 right up here on top of my denominator of 3. Now, I can slide over my bar to show 1/3, 2/3. So I know that I have 2/3 shaded of my model. If I look down here, I'm going to see that there is 2/3 being multiplied. So now, what about right here? I said I wanted to multiply by 2/5. Well, that 5 tells me that my denominator is 5, and that is how many pieces I need or that fit into my problem. So that means I'm going to need 5 rows. So when I shade, I'm going to see that I have 1/5, 2/5. Now, when I go ahead and take a peek at my shading, I'm going to see that 2/5 of multiplied by 2/3 would give me 1, 2, 3, 4, which are shaded, out of how many total? Well, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I know that I can also multiply my denominators to figure out what is my common denominator here. So 5 times 3 is 15. That also matches what I just double checked by counting. Now, 2 times 2 is 4. I also know that I can verify this by my shaded area right here. So when I hit check, I know that I'm going to see if my answer was correct. So 2/5 times 2/3 is going to give me 4/15. I'm going to go ahead and check it, and I know I'm correct. Can I simplify this problem? Can 4 and 15 reduce any further? I know the answer to that is no, as 4 is a multiple of 2. 15 being an odd number cannot be reduced by the number 2. 15, however, can be reduced by the number 1, 3, and 5. The number 3 and 5 cannot reduce the number 4 and still maintain a proper fraction. So I know that my answer is in simplest form.